Hi guys, in this video we're going to talk about multiplying and dividing radicals. Let's talk about multiplying radicals first. Last class we simplified radicals and we said the radical of two numbers or two factors multiplied by each other is equal to the radical of the first factor times the radical of the second factor. So today we're going to work backward. That means if we multiply two radicals by each other, the answer is going to be the radical of the product of these two numbers. What does that mean? Let's take a look at this example. We have radical 3 times radical 5. And to approach this problem, I need to find the product of 3 and 5. So I'm going to end up with radical 3 times 5. I know that 3 times 5 is 15, which makes me end with radical 15. Now, it's very important to ask yourself, is radical 15 in the simplest form? And the answer is yes, because I cannot think of two factors. If I multiply, I get 15, and one of them is a perfect square. Now, let's take a look at this example. We have radical 2 times radical 10. I know I need to multiply the numbers inside the radicals, so I have radical 2 times 10. Radical 2 times 10 is radical 20 because 2 times 10 is 20. Radical 20 is not in the simplest form. I can write radical 20 as radical 4 times 5. 4 is a perfect square. And then radical 4 times 5 can be written as radical 4, radical 5. I know that square root of 4 is 2, which makes me end up with 2 radical 5 in the simplest form. Now let's take a look at this example. We have 2 radical 3 times 3 radical 6. So the first thing I need to do is to address the numbers outside the radicals. 2 times 3 is 6. And then multiply the numbers under the radical. 3 times 6 is 18. So now I end up with 6 radical 18. I know that 18 can be written as radical 9 times 2, where 9 is a perfect square, which can also be written as 6 radical 9, radical 2. I know that square root of 9 is 3, which means that now I end up with two numbers that I can multiply. 6 times 3 is 18. So I end up with 18 radical 2. So that means 2 radical 3 times 3 radical 6 is equal to 18 radical 2 in the simplest form. Now let's talk about dividing radicals. One thing you need to know that if you have a radical divided by a radical, both of these two radicals can be in one radical and the numbers multiply and divided inside. What does that mean? Let's take a look at this example. We have radical 28 divided by radical 7. That means that these two radicals can be written into just one radical, where I have a big radical with 28 divided by 7 inside. I know that 28 divided by 7 is 4. That means I'm going to end up with radical 4. I know that the square root of 4 is 2. So 2 is the final answer. Let's take a look at this example where we have radical 10 divided by radical 2. We said that these two radicals divided by each other can be written as one radical, where these two numbers inside the radical divided by each other. So I'm going to end up with 10 divided by 2 inside the radical. 10 divided by 2 is 5. That means I'm going to end up with radical 5. Radical 5 is a simple radical that cannot be simplified more. Now let's take a look at this example where I have a radical 10 divided by 2. So in this example, I have a radical divided by a number and not a radical divided by a radical. That means that to approach this problem, I need to ask myself, do I have the radical in the simplest form? I have radical 10. I cannot think of two numbers if I multiply, I get 10, and one of them is a perfect square, which means radical 10 is in the simplest form, and this fraction is also in the simplest form because it cannot be simplified more. Now let's take a look at this example where we have 6 radical 10 divided by 2. So in this example, again, I have a radical divided by a number. So to approach this problem, I have to ask myself, is radical 10 in the simplest form? And from the slide before, we learned that radical 10 is in the simplest form and cannot be simplified more. But we have 6 as a number that can be divided by 2. So I'm going to divide 6 by 2, which gives me a 3, and radical 10 is going to stay the same. So the final answer is 3 radical 10. Now let's take a look at this example where we have radical 32 plus radical 2 over 4. So I have two terms added to each other at the top instead of just one term. So I have to ask myself, can I simplify the top of the fraction even more to be able to have a simpler problem? I have radical 32 plus radical 2. These two radicals are not like terms and cannot be combined together. But what I know is that radical 32 can be simplified into radical 16 times radical 2, because 16 times 2 is 32. So I'm going to end up with radical 16, radical 2 plus radical 2 over 4. I know that radical 16 is 4, so I have 4 radical 2 plus radical 2 over 4. Now I have like terms at the top of the fraction. 4 radical 2 plus 3 radical 2 is 5 radical 2. So I'm going to end up with 5 radical 2 over 4. Now, this fraction is in the simplest form and cannot be simplified anymore. So that's the final answer. Now, let's take a look at a different question where we have 8 plus radical 2 divided by 4. I'm looking at the, the expression at the top of the fraction, 8 plus radical 2, and these two like terms are not like terms and cannot be combined together. I know radical 2 is in the simplest form. So to approach this problem, I'm going to use this rule where it says that if I have two terms added to each other and then divided by a number, it can be written as the first term divided by the number plus the second term divided by the number. So 8 plus radical 2 equals 4 can be written as 8 divided by 4 plus radical 2 divided by 4. I know that 8 divided by 4 is 2. I know that radical 2 is in the simplest form, and when it's divided by 4 like that, we have a radical divided by a number, and this is in the simplest form. That means the final answer is 2 plus radical 2 divided by 4.